Hello, this is Ujjwal Kiran, a student of 8th semester Computer Science Department from MSRIT, presenting to you a video of how to use machine learning techniques based on a programming tool called R. I'm going to demonstrate how to install it and how to implement a machine learning algorithm called support vector machine based on the same. This is done under the guidance of our HOD sir Dr. KG Srinivasa. Hope you enjoy this presentation.
Now, let me tell you about the tool. R is free as its name suggests, it's an open source software. But one advantage of MATLAB is certain. It is an open source unlike MATLAB. We can have many packages for SVMs, clustering algorithms, etc. Even GPU programming can be done, GPU tools provided, but it's available only in Linux, not in Windows. R is portable, very available in any platform, be it Linux, Windows or into 64. Many packages like RText tools, E071, libraries are all commonplace now. These are used by big data researchers to efficiently find out the results of clustering algorithms. Enhanced tools like GPU harnessing of R leads to improved tuning, improved performance and more accuracy. Thus, R is one of the most popular software in spite of its a few drawbacks. Now, let me tell you about the classification part. Let us install the packages and select the Indian mirror which goes out of location. The basic essence of SVM classification is data is processed using K4 processing and divided in two sets, that is testing set and training set. Suppose there are n elements. If the testing set contains k elements, obviously the remaining training set will contain n minus k elements. Let us read the file for classification. These are the number of index rows which are used. Now let us define the testing set by this function. 30% of the data is testing set. Sorry, let us make it to 70% to test greater value. These are the indexes where the data is used as testing set. Now let us identify the data set for testing. These are the test samples. Remaining data sets obviously would be the training set. You can see saying displayed here. Now let's tune the SVM to find greater accuracy. Here K4 cross validation, best performance box. Here K is equal to 10. Thus K4 cross validation is implemented. Now let's go to detailed result, go to the summary. This will show you the more detailed performance result and the analysis post classification. Let's do this using radial model. Classification using radial model. To get here, let's do summary model. These are the training set. So 11 support vectors are there. Radial kernel functions are used. Let's do the prediction part now. At the end, let's conclude it by saying that taking the tabular column of all the test values. The moment you press tab, all these detailed values will come. Thus, the SVM classification perform. This is all about classifying data based on two sets, training and testing sets. Here, the tuning process is done to enhance results, and K4 cross validation and radial kernel functions are also used for the same reason. First, I am going to install a package called E1071. This package is actually required for running machine learning algorithm like SVM and custom. This command install packages so means it has to take care of all the dependencies in that package. It will ask you a clan mirror. Our location is India. So we have to choose India. This will take some time as it has to fetch the package from an external server and then download it. See, this package is now successfully downloaded. Now, in order to use the package, we need to use a function called library. Library E1071. Warning. But the warning message immediate because it's already built. Once again, if you build it, it's a warning. Either way, this package is now ready to use. Now I have a file called file called data in my folder. X values y. The basic idea of regression is how y values depend on x. 1 y becomes 3 when x is 1, y becomes 4 when x is 2, y becomes 16 when x is 20, and so on. This is the basic idea. Now we have to implement it using R in the concept of SVM regression, support vector machine regression. For this, to read the CSV file, we need to use a function called read.csv. Data, it reads into a variable called data. If you type data, then the red data which is red is displayed. Now we need to plot a graph based on x and y values, how y value depend on x. So is to use. See, this is the variation, but for regression is better to show a straight line. Line fitting is line fitting is essential. So we need to model the data and then plot a line. So LM function is used to model values of y based on x. AB line model. This function is used to plot the line model. You enter, then a line is passed. This line indicates the approximate line graph revolving around these points. But we need to get a clear view for this support vector machine classification. So we need to predict the values of y based on the model and data. That's the aim of this classification. This why this technique is regression actually designed to predict the values of y based on the given values of x. Predict. This uses prediction algorithms of machine learning techniques. Thus, these are the values of y which are predicted. It differs from these values because it's this based on the line plotted on this graph based on the values of x and y. Now points. Plot. We need to plot these points on the line. It should be in blue color. So for these points, function is used. See, clearly shows. These are clear indication of the data points that are present on the line. For greater accuracy, it's essential to minimize the errors present in the algorithm. So, an error function is used to determine, and based on that, we will try to reduce the error which affects the accuracy. This is done using root mean square technique. Let's find this value. Now, let's find out the other value. See, it clearly shows this. There are a lot of difference between these actual values. Our goal is to minimize errors so that the SVM technique is more accurate. Now let's predict the root mean square errors. See, the overall mean square error is high, 5.5. So let's try to reduce this error. Alternatively, we can predict the error by finding out the difference between the y values of data minus the predicted values of y. It's an alternative method. Error. Clearly, both techniques yield the same result. Thus, to reduce the error, a function called tune result is used. After finding value to result, performance. Performance 4.8. Thus, this much speed up is obtained because of 10-fold. Here, K4 cost validation techniques are used. In this, tenfold cost validation technique is used. Clearly, the value of K is 10. We are done with tuning now. Now, let's plot this tuned result. Sequential values need to be reduced to 0.01 for error accuracy in this case. Let's use the function called plot to result. Thus, this is the graph. Later means greater performance. So, our main objective is to perform the increased speed up in performance by actually reducing the error and enhancing the tuning. Now let's compare this performance. Clearly the performance in 20% speed up. Around 4.9 it has increased to 6. Now let's plot this graph. See, clearly the performance has improved and this graph has an indication of that. Based on the tuned model, let's find the y coordinates based on the tuned regression technique. Let's find out the values now. Thus, based on this, clearly there is some accuracy as compared to the previous version. The graph may be same, but errors are significantly reduced. find out the error. Clearly, as compared to the previous example, the errors have significantly reduced as seen in the values. Now, let's find the root mean square error. When we find out, clearly this error is reduced from around 5.6 to 1.9. Thus, around 67 or 68% reduction. This technique improves greater accuracy and more efficiency of support vector machines. Thus, this is the benefit of tuning. Thus, I would like to conclude my video presentation by thanking our HOD sir and all the faculty, staff and students for the support they have given to me during this presentation. This is Ujjwal Kiran signing off. Thank you.